Assalamualaikum and good day everyone. So today we are going to proceed with the last properties of inverse Laplace transform, which is rational function. Inverse Laplace transform of rational function, or we can call it partial fraction. Okay, so basically you already learned this one in your maths one. This one. Okay, so this is a rational function, or we call it partial fraction. Okay, the difference is just during your maths one, for you are using a variable x. Okay, but in this case we are using s, since you are involved with inverse Laplace. Okay, from s to t. Okay, so we have a linear factor, repeated linear, quadratic factor, and repeated quadratic function. Okay, so let's take a look at the example of each of this one. Okay, so let's say, so the first one is linear factor. Linear factor. So let's say you have for the denominator part s plus 3, s minus 1. So this is a linear factor. You have two different functions. So the partial fraction will be a over s plus 3 plus b over s minus 1. Okay. So the second one is repeated linear. Repeated linear. So let's say you have s plus 3 squared. Okay, so this is repeated linear because this function repeats twice, 2 times. So what is the partial fraction? So you will have a over s plus 3 plus b over s plus 3 the whole thing squared. Okay, so this is the first one, this is the second one. You stop when you have your n, since your n is equals to 2, then you stop when this one is equals to 2. Okay, so if you have cube here, then you have to add another one, plus c over s plus 3 the whole thing cube. Okay, so the third one is quadratic factor. Quadratic factor, if your denominator in terms of as squared plus bs plus c. Okay, remember you just need to apply this one even only if you cannot factorize the denominator. Okay, even only if you cannot factorize the denominator, or you cannot factorize the quadratic function. Okay, so let's say if you have for the denominator part, you have s squared plus 1. So this is a quadratic function, and as you can see, this one you cannot factorize. Okay, if you use your calculator here, so your a is equals to 1, your b is equals to 0, your c is equals to 1. So as you can see here, you have the imaginary part I, which means this function cannot be factorized. Okay, so therefore the partial fraction of this function will be as plus b over s squared plus 1. Okay, and the last one is repeated quadratic function. Okay, let's say for your denominator part, you have a quadratic function, which is, let's say, this one, s squared plus 1, and this is repeated, so which means greater than 1. So let's say you have squared here. Okay, so what will be your partial fraction? As plus b over s squared plus 1, so this is the first one, plus, so the second one will be cs plus d over s squared plus 1 the whole thing squared. So you stop when this one is equals to this one. Okay, so for rational function or partial fraction, you have either linear factor or repeated linear, or you might also have quadratic factor, and the last one is repeated quadratic function. Okay, but usually when we have a problem, it might be combined 1 and 3 or 2 and 3. Okay, so let's take a look at the example on how to solve the inverse of the function by using rational function. Okay, so let's say you have this function. So your fs is equals to 1 over s plus 1 s minus 2. Okay, so we need to apply properties of inverse Laplace transform because you cannot get the inverse of this function directly from the table. So that's why you are using properties. Okay, so as you take a look at the function here, the only properties that is suitable to use is partial fraction or rational function. You have to think on your own which properties that you are going to use. Okay, remember we use properties to make it easier for you to get the inverse of the function. If the properties that you choose will make the problem more complicated, then that properties might be wrong. You cannot choose that properties. Okay, so for this one you have to use partial fraction. So when we're dealing with partial fraction or rational function, you need to consider the denominator part here, because you have to know either this is a linear factor or repeated linear or quadratic function or repeated quadratic function. Okay, so as you can see here, you have two linear factor. This is the first one and this is the second one. Okay, so you are using the first one, which is linear factor. Okay, so therefore 1 over s plus 1 s minus 2 is equals to a over s plus 1 plus b over s minus 2. Okay, so as you can see here, instead of finding the inverse of this function, now by using properties, you just need to get the inverse of this function. And as you can see, you can directly get this one from the table. But before we proceed, you need to get the value of a and b. Okay, so this is the first step, which is determine your partial fraction. So the second one is you need to get the value of a and b. Okay. Before you can find the value of a and b, before you can compare left hand side with right hand side, you need to make sure this one, what you have on your left hand side, is equal to what you have on your right hand side. Okay, so 1 is equals to, we just consider the numerator part because you want to find the value of a and b. So a, so as you can see for the first function here, you compare the denominator part. This is s plus 1, this is s plus 1, so what is missing? S minus 2. Okay, so that's why you need to multiply by s minus 2. Okay, plus second one is b. So now you compare the denominator for this function. Now you have s minus 2. Okay, so you already have this function. So what is missing, the functions missing is this one, s plus 1. So that's why you need to multiply by s plus 1. Okay, so the next step is expand the whole expression here. So you will have as minus 2a plus bs plus b. Okay, just expand. Okay, then factorize according to the function. So the first one is variable s, so you will have this one and also this one. So you will have a plus b s. Okay, and the rest will be negative 2a plus b. This one is equals to 1. Okay, so now for you to get the value of a and b, you have to form two equations. Remember, when you have two unknown, then you will have two equations. So what will be the first equation? So you are comparing left hand side and right hand side. So as you can see, on your left hand side you don't have any variable s. Okay, so your first equation will be a plus b is equals to 0. Why 0? Because you don't have variable s on your left hand side. Okay, so the second equation involve a constant. So this is a constant and this is a constant, the whole thing here. So you will have negative 2a plus b is equals to, so you have a constant on your left hand side which is equals to 1. So you will have two equations. So you can use either elimination method or substitution method for you to get the value of a and b, but the easiest is by using calculator. Okay, so how we are going to find the value of a and b by using calculator? So first you need to set this one equation. So now you are dealing with unknown, okay, not degree. Okay, you are dealing with unknown. So how many unknown you have? 2, a and b. Okay, so your a1 is referred to your first equation. Okay, this column will represent your a, this is b, and this is c. Okay, so equation 1, your a1 is equals to 1, your b1 is equals to 1, and your c is equals to 0. Okay, the second equation, your a2 is equals to negative 2, your b2 is equals to 1, and your c2 is equals to 1. You don't need to move this one to the side. Okay, just take whatever value you have. Okay, so your c2 is equals to 1. So therefore you will have this one. As you can see, this is x. So how are you going to know which one is a and which one is b? Depends on how you write this equation. So if you write your first term as your a, so the first value will be your a. Okay, so therefore you will have your a is equals to negative 1 over 3, and your b is equals to 1 over 3. Okay, so now you can substitute into this one. So therefore the inverse of 1 over s plus 1 s minus 2 is equals to, so your a is equals to negative 1 over 3. Negative 1 over 3 is a constant, so you can factorize. So negative 1 over 3, so you just need to find the inverse of 1 over s plus 1 plus your b is equals to 1 over 3. So this is your constant, so factorize it. Okay, so you just need to find the inverse of 1 over s minus 2. Okay, so therefore since this is your fs, so therefore your ft is equals to negative 1 over 3. So this one you don't need any other properties for you to get the inverse, because this is directly from the table. So the inverse of this one will give you exponent negative t plus 1 over 3 exponent 2t. So therefore this is your answer. Okay. So this is how rational function works for you to get the inverse of the function. So let's just try the second example. So let's say you have your fs is equals to 2s plus 1 over s squared s minus 3. Okay, so take a look at the denominator part. So you know that the first, this one is repeated factor. Okay, and this one is a linear factor. Okay, so this one is repeated linear factor. So what will be your partial fraction? So 2s plus 1 over s squared s minus 3. So this is a combination of case 1 and 2. Okay, because this is linear and this is repeated. So remember, when we are dealing with a repeated function, you stop until your n is equals to 2. So therefore, your first partial fraction will be a over s plus b over s squared plus c over, so the last one is s minus 3. So instead of finding the inverse of this one, now you just have to find the inverse of this function. Okay. So the next step is for you to get the value of a, b and c. Okay, for you to get the value of a, b and c, we need to compare left hand side with your right hand side. Okay, for the numerator part. So for this one, you have 2s plus 1 is equals to, so the first one is a. So take a look at the denominator here. You are going to compare this one with this function. So what is missing? This is s. What you need is s squared. So you need to multiply by s. Then s multiplied by s, then only you have s squared. And another term that is missing is s minus 3. Good. Okay. So the second one is plus b. So compare the denominator part. So you already have the s squared. So you just left with s minus 3. So that's why you need to multiply only with s minus 3. Okay. And for the last one, plus c. So as you can see here, for c you already have s minus 3. So therefore you need to multiply only by s squared. Okay. Remember, this one you cannot use a cross multiply. That is wrong. This one multiplied by this one, this one. This one multiplied by this one and this one. That is wrong. Okay. You need to make sure that the denominator of this one and this one is equal to this one. Then only you can compare left hand side of this one with the right hand side function. Okay, so that's why I teach you, you compare what term is missing, then multiply by that term or function. Okay, so the next step is expand the whole function here. So you will have as squared minus 3as plus bs minus 3b plus cs squared. Okay, now factorize back according to the variable. So the first one is s squared. So find which of the term that have s squared. So you will have this one and also this one. So therefore your first function will be a plus c s squared plus the second one is s. Which one that you have the variable s? This one and also this one. So you will have plus negative 3a plus b. I always remind my student you just use the notation plus notation. Okay, so if you have negative, then just put negative in the bracket. If you want to use negative here, then you need to rearrange what you have here so that when you expand you will get the same as before. Okay, so for you not to make a silly mistake, so just use plus plus plus, and if you have negative, so put in the bracket. Okay, so negative 3a plus b s, and the last one is a constant, which is this one, negative 3b. Okay, so now we already factorize according to the variable s squared, s, and also a constant. Now form an equation. So as you can see here, you involved with three unknown. So you must have three equation. So what will be the first equation? The one with s squared. Okay. So what will be the equation? A plus c is equals to, so do you have any s squared on your left hand side? No. So that's why you have a plus c is equals to 0. So this is the first function. So the second one is with the variable s. So this one. So negative 3a plus b is equals to, so on your left hand side you have 2. So this is your equation 2. And the last one is compare with s0, which is equals to 1. This is constant. S0 is equals to 1. Okay. So what is your constant here? This one. Negative 3b is equals to 1. So this is your third equation. So when you have a these three equation, so just use your calculator for you to get the value of a, b, and c. Okay, so set this one, equation unknown 3. So the first equation will be your a1 is equals to 1, b 0, c is equals to 1, and your d is equals to 0. The second one, your a2 is equals to negative 3, your b is equals to 1, you don't have your c, so 0, and your d is equals to 2. And the last one, a is equals to 0, b is equals to negative 3, c is equals to 0, and your d is equals to 1. Okay, so therefore the first one will be the value of a. Therefore your a is equals to negative 7 over 9. Your b is equals to negative 1 over 3, and your c is equals to 7 over 9. Okay, so now you already have the value of a, b, and c, so you can substitute back into this one and get the inverse of the function. So therefore your ft is equals to, so the first one is a over s. So what is your a? Your a is equals to negative 7 over 9. So this one is a constant. So factorize. So negative 7 over 9 Laplace inverse of 1 over s. Minus 1 over 3 because your b, this is a constant. So you just need to find the inverse of 1 over s squared. And the last one is plus 7 over 9 Laplace inverse of, so what is your function for c? 1 over s minus 3. Okay, so as you can see, this one you can get directly from the table. So 1 over s is equals to 1. So therefore your ft is equals to negative 7 over 9 minus, so this one will be t. Okay, why? Because you have n plus 1. N plus 1 is equals to 2 and your n is equals to 1. So this is already 1. Okay, so you will have tn. Your n is equals to 1, so you have t. So negative 1 over 3t, and the last one is plus 7 over 9. So this one will be exponential function. Exponent 3t. That's it. Okay. So in my next video, we will proceed with another two example. Okay. So stay tuned. Thank you guys.